let's start. We're going to talk today about the crashes and handling crashes. And my name is Igor, and I'm working as a software developer. Started in 2007, and now I work for Unity Technologies in the last few years, where we're building tools to increase productivity of the R&D teams and QAs and testers. So everyone knows Unity here. For those who don't know, we'll do a quick fact check. So Unity is a platform for game developers to build their games. It's an engine and the editor, which allows you to build games and then publish them to now more than like almost 30 platforms. And so what we do at Unity as a Toolsmiths, we help things to run smoothly. We help teams with infrastructure, with tests, testing framework, and also the bug reporting infrastructure. That's what we care about. And let's briefly talk about what is reporting bugs in Unity. So Unity, as I said, the editor itself ships with a bug reporting tool, which we call Bug Reporter, and it allows users to send us any bug reports along with the logs and projects to attach to it, along with description of the problem, and then it gets processed on the server on the backend. The ticket gets created in our bug management system, which is FogBugz. It's quite like a Jira, basically, but it's yeah. And then someone from the QA or support teams has to pick up that ticket and try to reproduce it before it's handed to the developers for the resolution. And it's perfectly worked until it stopped. Because like these days, we have more than 1 million registered users, and the amount of reports coming to us is like more than 6,000 a month. So, and yeah, it's quite a big number. And as I said, like everyone should be looked at and reproduced before we can make any sense out of it. And it turned out like only like 15% of all the reports turn valid bugs. Why is that? Like some of them are already known problems, maybe even fixed problems, because people tend to stay on later, like not the latest versions, like the older versions of the software, and yeah. And sometimes some of them are just not well described. We can't reproduce them. So essentially, it puts like 80% or more of this work is duplicate and waste for our team, which means it's worse quality for everyone. And yeah, obviously when we can't handle everything, the crashes should be the first priority out of all the bugs. But it turned out we are in complete dark regarding these bugs and crashes, because like as I told you, all the reports get in our bug management system, and then we can't tell the difference between the crash, between the regular bug. We can't say if the two crashes are the same or not, because it's just a user report with some description. And yeah, it's a lot of duplicate work, because we have to open the report, we have to look into the logs, we have to figure out what's happening. So obviously, we are the automation heroes here to address these things. And the really first question we asked ourselves was, should we build our own system for that? Or maybe we just better off adopt one of the existing system, which is, of course, simpler. Should be, right? So we looked at one of those, which is Socorro. It's from Mozilla, and they use it for the Firefox browser. And it's the server, processing server, and the reporting UI, which allows you to sort things, to group things. But, well, it's open sourced and written in Python. And on paper, you can use it for your needs. But it turned out it's so much, it's so complicated, and it's like it took us literally a few weeks to even to try to run the system and we failed. I have to confess, we failed miserably with it. And if you Google the cross-platform crash reporting, you will find that, yeah, one of the first links on the Stack Overflow will tell you about the Socorro, and then it's actually sucks. You can do anything with it. It's too complicated. It's obfuscated, and yeah. So basically, and more than that, it expects it's only the server, and it expects Breakpad as your library to actually collect and report those crashes. And Breakpad itself is a very nice library written by Google and open sourced by Google. It allows you to do nice stuff like separate the PDBs, like the symbols from your app, and distribute your app without the symbols, and then process everything on the server, like just they collect mini dump and send. But it has a few drawbacks also. It's only the system for collecting crashes and no reporting server. It requires something to either build your own or use one of the existing. And what was more important for us, it could not resolve mono frames. The C#, we have a C# over mono, like we have a C++ core, obviously, for the engine, and also a lot of C# mono code interacting with it, and we couldn't get the crashes from mono resolved with Breakpad either when we started to look into this library. So we asked ourselves, well, should we do this? Because, like, yeah, we already have crash collecting system, and it works on mono also. And yeah, the main problem we currently try to deal with is all these reports already sitting in our bug management system, all the stuff users send us, and we can't process, can't handle. Our manual testers who try to reproduce this stuff are overflowed with the work, with the reports. So in the words of Bert Lance, basically, if it works, yeah, like if it ain't broke, don't fix it. So why spend time on fixing the stuff already works for us, which is collecting crashes, if we need to really make some sense out of processing those reports and processing these crashes. So we end up building our own system, and the first step, obvious step, was to collect, to parse existing logs and try to match the call stacks. And parsing was quite trivial. We had just to walk the traverse our bug management system, go through every ticket, get the logs, parse them. But then matching, it was quite a hard problem. We came up with the idea of the bucketing, which was actually inspired by the Windows error processing system and how they do their stuff. So the idea is basically to group reports into the groups, so-called buckets, with the goal being one root cause per the bucket. So the one problem, all the reports related to one problem should sit in one tight bucket, so they're easy to solve and address, which is a basic principle we all use in software, right? To divide and conquer, to find the biggest problems first, to attack them first. So like by fixing the one bucket, we can fix a lot of problems for our user. But the problem with matching, it turned out that, like, first we tried to do full matching. Like we got a call stack, and we tried to match it to other call stack, and to see if are the same. But this attempt also failed for us, because it turned out like we took the 20,000 crash reports, like for experimenting with them, and turned out about two-thirds of them were unique. Like we didn't get far away with this bucketing. Like we still had a lot of buckets and groups and problems to process. So we started to look other way. What if we just group the call stacks by only the top frame, which is obviously the function which crashed. And if two crashes crashed in the same function, obviously they are related. And that's maybe a good idea to group them. But then there is other problem. Let's say we have a crash in some of the system calls, like division by 0 or something like that. Is it wise to group by that? Like, isn't this problem, the source of the problem somewhere in our code, some faulty state, which then led to this crash? So is it better to try to look in our code? So that's what we did. We introduced the notion of the gist, which is basically the stripped down version of the call stack, where we throw away all the system calls, all the standard library calls, the login calls, everything we deem like it could be the source of the problem, right? Like we want only to look at our code. So with that idea, we were able to group everything and use both grouping techniques I've mentioned with the full matching and the top frame matching, but this time only on this stripped down version of the call stack, the GIST, and it gave us a much better picture. So out of the recent numbers, like we had about 80,000 reports in total, which are grouped into 20,000 unique crashes and like 4,000 buckets. And it looks like that on our, probably can see it very good, but yeah, the idea is to just, there's the crashes, like the similar crashes with the GISTs, which are a little bit different, but they all end up in the same function, which gives the name for the bucket, which is a transform internal destroy transform hierarchy in this place. And it allows us to now to group everything, to see some metrics, to see some counts in every crash, in every bucket. We can see the earliest version it started to appear. We can see the latest version it's still there, like if maybe it's fixed, and we can see it in latest versions. So yeah, naturally it's time to go quickly through some benefits, which we were allowed to unlock after we did this matching. So the first one is obviously the visibility. We were really lacking what we were talking about in the beginning. So now we can do easily search stuff, we can filter, we can group by the versions, we can filter by the status, like if it's active or if it's closed, resolved, and so on. We have easy navigation from into FogBugz, which is still our source of truth for all the cases. They're still there. We just built our system like close to it, so we can interact. Like now we can like remember the problem I mentioned. Like it was just all the reports and they had no relation in FogBugz. Now we can just easily open all the related reports, like from one bucket by one click. You can open all this list in the FogBugz and do stuff like edit or close them all together, for example. And vice versa, like if you have a case number to investigate, like say users on the support, on the premium support came to you and say, hey, this is my case number, I want it to get fixed. So you can easily open it in our system and see which bucket and which crash it relates to. You can look around to see similar problems and try to make sense out of it. Another interesting use case we've got from our system was this monthly report. Our support team started to form and send to all the company, to the developers, to the testers, which basically the top crashes, like the most active ones. We have the most user reports in, which obviously are the biggest problems which are worrying our users, and they should be addressed first. So that's very useful report. Another idea is to actually look at the crashes when they happen the first time. And it's maybe a good time to fix them before they end up in this top report, right? So like we did a Slack integration for that, and as soon as we get something new, like the call stack we never seen before, we post this information on the Slack channel, so developers can see like if it's related to their part of the code and fix it, even in some betas, right, before it makes the production and hits the users. Finally, the duplicate thing, like this big problem, which was putting a lot of extra work and waste on our teams. Now we're able to solve it too. Like as soon as the new report comes in, we try to match it to group to the bucket it belongs. And the first question we need to answer, like, do we have a repro for this bucket already? Like, do we have a report which was successfully reproduced? So do we have enough information about the problem? And maybe the problem is already fixed. And maybe the fix is even released in public in some of the patches or newer versions. So now, as soon as new report comes, there's another Slack channel, and we post all this information we know about these reports literally in seconds. So the person who will handle this report know all the information he needs or she needs at their hands, and they can make a decision right away. Like if it's a duplicate, if it's already known problem, or vice versa, if it's something new, something different, and we need to ask users for maybe more information and more detailed repro steps and so on. Yeah, so that's all stuff we already built and have, and there are some more ideas we are currently working on and want to implement in the future. And one of them is so-called online processing, which is the idea of the duplicates, just taking one step further back to the client. Like instead of processing all the reports on the server when they're already submitted, why can't we look at them right when the crash happened? Like as soon as crash happened, we send some logs to the server, we analyze them, we bucket them, and then we can reply. If it's, do we need this report? Like, do we know the fix for this problem? Like, so basically we can make the decision right away and not waste the user's time to fill the report for us, and again, save time on our teams to investigate the report. And this comes along with another thing, with another option to actually improve, which is to improve the crash collecting itself. Like remember what I told you, like we had the biggest problem on the processing end, right? Like we had the crash collecting, but we couldn't handle it. And now it's time to maybe go back and like when we can handle a lot of stuff, now we can improve the collecting part. So like this is actually the ideas from the Breakpad itself, from the library I mentioned. So like the first one is out-of-process crash handling, which is considered better practice when you just have another process like the watchdog sitting, and the application starts and registers itself in this watchdog and says, okay, I'm the application, I'm interested in like this kind of stuff. Like when I crash, you just send report. So this another process. It collects already like most of the needed information, like the system information and environment and so on, which gets sent with a bug report. So as soon as the crash happens, it only needs to collect the call stack, the stack information, to pack it into the minidump format, which is Windows format used by this Breakpad library, and send out, which is faster and more efficient, and so on. So bucketing. Bucketing is still a hard problem because, like, yeah, we only scratched the surface basically with all this matching and gists, and like there's still some buckets when we can't tell, like the ultimate goal of having one root cause, one source of problem per bucket, it's still not reached and still not 100%. Like for some buckets, it's true, like the call stack is good enough identifier for the problem, and for some of them, like say in drivers, that's not. Like you can have the similar the matching call stacks, but the problem would be different, like depending on the parameters, on the environment, and so on and so on. So we have to do to introduce more tools to maybe do some manual splitting of the buckets or combining of the buckets. If someone comes and say, okay, this problem should be in different buckets or in the same buckets, and maybe we should have some tools like machine learning to help group them, like to maybe investigate some the most common functions of the stack, not only the top one or the full one. To get a better ideas on how to group this thing. And when we finally have a good bucketing, the wise thing is to do the next step and come from the problem to solution. So every crash, every bucket has to have some source of problems, right? Which we want to map to the actual source code. Like we have a lot of subsystems in Unity, say graphics, physics, and so on. So what we want to do if you have a bucket, if you have a crash, we want to have a mapping to the code and to the subsystem and to the developers who actually can take care of it. So out of all those big numbers and big crashes numbers we have, we can just pin the right people and make them do work and improve stuff. So the conclusions from this. The first one is kind of obvious, right? It's obvious, but we still need to make sure we do this. Like, if it's not your core business, you probably should not spend a lot of time trying to build this if you can find a good solution which works for you. Like, for us, it was different. We couldn't find it, so we had to build our own. But maybe you will be lucky for your problem. And if you really need cross-platform crash collecting, consider using Breakpad, which is a good library. It allows you to do some good things. And yeah, focus on one problem when you're trying to. It's again something like generic advice, but that's really how it should be. Like, and really, as a software developers, we tend to forget about this when we're trying to handle some problems. Because like in our case, we could easily start with doing something fancy like this online crash processing. But again, it makes no sense if you can't actually handle the reports on the server, if you can't match them. So to try to improve stuff or to like integrate the Breakpad instead of our working solution. But again, like the main problem we had was to deal with those reports already in our system. So yeah, and finally the bucketing. The bucketing is the powerful instrument no matter what you're doing. Like if you have a large set of problems, try to divide them into smaller subset and focus on those which can bring you the most value tomorrow, right? The 80-20% rule, the Pareto distribution applies here. Like 20% of the code or the bugs are affecting 80% of our users, right? So if we can fix those 20%, we will do a lot of better than if we start with something else. And even if we can automate like 50% out of those thousands of reports, it's still better. It still saves time for developers and for testers to do stuff. And finally, the crash reporting and bug reporting. What we learned, it probably was the better idea to split them in the beginning. Don't have them sitting in one big system, because it was really hard to distinguish between them. And the crash reports are really what you want to automate, I believe, because it's the thing you want to, like, the computers are better at doing tasks which are almost the same, right, and repeatable. So, and the manual bug reporting tends to take a lot of resources and a lot of effort. Finally, there are some links on the topic. So if you're interested in crash collecting, crash reportings, you should read those. Those I mentioned, like from the Microsoft system. Their system is not open sourced, obviously, because it's Microsoft. But they share a lot of the good ideas, how they do their stuff, and we grabbed a lot of those ideas out of them. And finally, the pages for the Socorro and Breakpad. They have also a lot of useful information on crash collecting. And yeah, so join me on social networks I use for my professional interaction with developers and people. And thank you for coming to my talk. Now we can go to the questions, if you have those.
Yeah, one question. You focus a lot on crashes here.
Yes.
And I understand your bucketing method for that, but I didn't. Perhaps you talked about it, but I missed it. But do you actually do the same thing for bug reports in other aspects of the tool, or how do you treat those?
No. So the question is like, do we only automate those crashes, or we also automate some of the bug reporting, right? Okay. No, so we only focused on the crashes because, as I said, like it's the thing you really want to automate, because it has like one common thing in it, like the call stack. You can like use the machine to identify the call stacks if are the same or not. And for other bugs, like the initial problem we were facing, like it's all the text, right? It's a description of the user's problem, so it's pretty like arbitrary, right? It's arbitrary text. We have problems there and here, and so you can't group this thing like if it's just a text with a description. So for this now we still rely on the.
Stack Overflow has this really interesting feature when you start to type a description of a bug, it will actually put up suggestions.
Okay, with tags and stuff, and even like the analyzing of the words of the problem.
Yes, I don't know how to do it. But
yeah.
It's accurate.
Yeah, sure. So I think they put a lot of like the machine learning and all this algorithm. No, we don't have this. Like we only have to make the crashes thing, and like other bugs still have to be processed manually. Thank you. Any more questions?
Okay. I have one
Sure. Go for it.
What's the, if you look at the number of bugs you get, how many are actually crashes and how many are written reports?
Okay.
Percentage?
Yeah, that's an interesting question. I believe I don't have this answer right now because, like, yeah.
50 or 90-10?
No. I mean, I believe the non-crashes are much more because, like, the system is big and like there are all sorts of problems. Like sometimes users just write us the report like they can't handle the stuff. Like they can't figure out how to do something, and they just fire the report. Like, okay, I can do this and that. It's written in manual. It's in the docs. Like, but I can't do it. Like, help me out. Like, and we have kind of those discussions. So no, I would assume, like, I don't have the exact number because, like, yeah, in our system we only take care about the crashes. But yeah, the crashes are the small subset of all the bug reports coming. Yeah. Okay, so thank you. I think that's it.